Hey, good afternoon, everybody. Sorry I can't be with you guys today. We were going to spend the day just practicing factoring quadratics anyway. So what I'm going to do is put together this little video, which we would have done in class, and you guys can follow along with the video. I would recommend trying to do the factor the expressions as we go along, or as I go along, to practice and kind of check yourself against me. And then I'll also get into some special cases at the end where things aren't quite as straightforward. So let's get started. So how can we take a quadratic expression that is an expanded standard form and put it into factored form? The first one we want to look at is x squared plus 6x plus 5. And whenever you have a kind of plus situation, when everything's adding, those are the most straightforward, right? Because you know everything is going to be positive. You're going to have an x plus something and x plus something else, okay? So factor pairs of 5, right? I look at my factor pairs of 5 because that's my C term, and that's the one I know I'm going to have to get a 5 in that upper right-hand corner box. And because 5 is a prime number, I know the factor pairs of, the only factor pair of 5 is 1 and 5, right? So I'm just going to put that over on the side. You don't have to write them down. You can if it helps you, but it's just kind of there as a list of potential things that you can use. I also know that the only way I can make x squared is by multiplying x times x. So if I'm going to set up my area model, the first thing that I want to do is I just want to put my two x's in there, right? Now, I need my other two spaces on the outside filled, the one above the x on the left and the one to the right of the x on the bottom. And I know in order to make 5, honestly, my only options are 1 and 5, right? So I'm going to put a 5 and a 1. And now, every single time you factor, you want to double check that you actually get back to where you started from. So I'm going to check and say, okay, does this actually, if I expanded this, would this give me x squared plus 6x plus 5? So x times x give me x squared, x times 5 gives me 5x, 1 times x gives me 1x, and 1 times 5 gives me 5, right? So I know I'm going to combine those two. That's my O and my I box, my outer and my inner. And if I combine those two, I will get 6x, so I have x squared plus 6x plus 5. Now, I want to point out right now that not every expression, quadratic expression, is factorable. Actually, most of them aren't, okay? But this one is, because x squared plus 6x plus 5, because 5 plus 1 equals 6. But if this were x squared plus 7x plus 5, we wouldn't be able to factor it, right? Because there's no way I can manipulate the x's and the 5 and the 1 to give me 7, right? I can only work it to give me a 6x. So not every expression is factorable, but today we're only dealing with ones that are. Okay, so let's look at another example that has more factor pairs than just 1 and 5. So that would be x squared plus 10x plus 24. So I know I'm going to go ahead and list all my factor pairs of 24 because I know in that top right box I'm going to need 24. And there's only a limited number of ways to get there, right? I've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So the next question I ask myself is I know, right, if I'm going to be using these numbers, either the 1 and the 24, the 2 and the 12, the 3 and the 8, the 4 and the 6, and I know that I've got x squared plus 10x plus 24. Because those are all positives, I know I'm going to be adding all the time. I'm going to have x plus something and x plus something else. So I've got to ask myself, of these factor pairs, which ones would combine to give me 10x? So I look down my list, oh look, 4 and 6. Those are going to combine to give me 10x. So now I go ahead and I set everything up. And I say, okay, I know the only way to make x squared is x times x. I know I can make 24 with 6 and 4, and that should give me, if I look, that should give me 4x and 6x in those boxes. And I know that 6 times 4 will give me 24. So let's go ahead and check. Like I said, you always need to double check. So x times x is x squared, then x times 6 is 6x, 4 times x is 4x, and 6 times 4 is 24. And then I do my check, does the 4x and the 6x, do those combine to make 10x? Yes, they do. I'm good to go. I've factored it, so it's x plus 4 times x plus 6. All right. Uh-oh, now we've got negatives. We've got x squared minus 2x minus 8. The good news is nothing really changes. The only thing that changes is that instead of having a plus plus situation here, in order to get -8 or -8 at the end, you're going to have an x plus something and an x minus something, because the positive times a negative will give you the negative at the end. So you think about that when you're thinking about your factor pairs. What factor pairs will actually give you -8? Okay? Not think about what factor pairs will give you 8. Think about what factor pairs will give you -8. So let's list them out. We could have 1 and -8. That would give me -8. You could have -1 and 8. That would give me -8. 2 and -4, and -2 and +4. So the next thing I'm going to do is I'm going to do that same thing I did before and say which factor pair here in my list would give me -2x in the middle, right? So let me think about it. And I think, okay, well, what would give me -2x? Well, if I had a -4x and a +2x, right, that would give me, if I combine those two together, that would give me -2x. So which factor pair is going to give me that? Well, if I look back at my list, I need a -4 and a +2. So the third one down, the 2, -4, will give me that. So how does that actually work out? Well, I still know that I need x times x to give me x squared, right? Then I'm going to need the -4 to give me -4x, and I'm going to need the +2 to give me +2x. So x times x will give me x squared. Then I already knew I needed the 2x and the -4x, so x times 2 gives me 2x, -4 times x gives me -4x, and then -2 times 4 gives me -x. So if I were to actually write it all out, I have to remember that the negative in front of the 4 means x minus 4, and then I have x plus 2 across the bottom. So my factored form would be x plus 2 times x minus 4. So those are just some basic examples of when you've got some positives, some negatives. You could have a situation like the one we have here where you have something like x squared plus 2x minus 8, right? And the only thing that would change there is that you would use the other pair. You would use the -2, +4 pair, because that would end up giving you a +2x instead of a -2x. So let's look at some special cases, right? So here we've got one where they've kind of changed the order around on us. And if you look, 5x plus 50 minus x squared, that's actually, the sign in front of the x squared is negative. So I'm just going to rewrite it in the order of -x squared plus 5x plus 50. If they give it to you out of order, put it in order. It's much easier to think about. So same thing here. I'm going to ask myself, what are my factor pairs of 50? I'm going to have to deal with that negative in front of the x squared, but I can deal with that in a minute. First thing I still want to do is ask myself, what are the factor pairs of 50? And that's 150, 225, and 510. So then I'm going to go ahead and say, okay, just looking at my 3 factor pairs, which one is most likely to combine in some way to give me that 5x term in the middle? And if I look at combining the first one, 1 and 50, there's no way I can combine 1 and 50 if I'm putting them together to give me 5. And there's no way I can combine 2 and 25 to give me 5. But there is definitely some ways, depending on what is positive and what is negative, that I can combine 5 and 10 to give me +5, right? To get that plus 5x term in the middle. Okay, so I know, again, I've got to make x squared, but this time I have to make -x squared, right? So the way I'm going to make a -x squared is by multiplying x times -x, right? So x times x is x squared, but one of them is negative. A negative times a positive is a negative, right? And then I'm going to think to myself, what would I need in my O and my I boxes, right? These boxes, what would I need to give me positive 5x, right? And I would know I need, in order for that to happen, if I've got a 10 and 5, I'm essentially going to need 10 minus 5, or 10x's take away 5x's, and that would give me plus 5x. Okay, so I'm going to think, how am I going to get that? Because I've got this negative x down here, right? And that negative x is going to make whatever I multiply it by it negative. And I need the 5 to be the negative one, right? I need to end up with -5x here, right? And I've got my negative x down at the bottom. So that tells me, if I looked over at my factor pairs, both my factor pairs, because it's for positive 50, both the numbers in my factor pairs are positive. So if I multiply a positive 5 times a negative x, that'll give me negative 5x, right? And I need to end up with 10x in the other box, right? So that would have to multiply that 10 by just the regular positive x to get positive 10x. Okay, so if I need to end up with negative 5x up in the upper left-hand corner, and I know I have negative x down here at the bottom, I can go ahead and I can put my 5 right there, because the negative x times 5 will give me negative 5x. And then I can put my 10 over here, because x times 10 will give me positive 10x, and then x times x would give me negative x squared, and 5 times 10 would give me 50. So now I can look, I say I have negative x squared, 10x minus 5x will give me plus 5x, which is what I have in my expression. And at the end, I have positive 50. So my expression would be, fully factored expression would be x plus 5 times negative x plus 10. Don't think I wrote that one out. Okay, what do we do when a isn't 1? Okay, what do we have 2x plus 11 squared? 2x squared plus 11x plus 5. Keep using 5. Sorry, I didn't mean to use 5 so many times, but it just worked out that way. Again, 5, I've still got to look at my factor pairs. I still need 5 in that final box, and my only factor pairs for 5 are 1 and 5. Now, if you had an expression like this where you had a 2 at the start and then a number that had more than one set of factor pairs, those ones you're going to have to do a little bit more trial and error with. But because you only have one option here, right, we only have 1 and 5 as a factor pair, it kind of limits our options, so it's a good example problem. So I know I'm going to need a 1 and a 5, right? In order to get that 5 in that last box, I'm going to need a 1 and a 5. So I'm just going to go ahead and put them in now, right? Now the only way to get 2x squared is to multiply 2x times x. So the question is, on which side of my lower level box, my lower left-hand box, does the 2x go, and which side does the x go, right? Because I need it to all work out to give me 11x in the middle. So if I'm looking at 1 and 5, I've got to think about which one do I want to get multiplied by the 2, right? Because I've got to get up to 11, and I only have 5 and 1 at the moment. So I just do a little thinking ahead and go, well, 5 times 2 is 10, and 10 plus 1 is 11. So it's going to make sense for me to put the 2x where it's going to get multiplied by the 5, okay? So if I put the 2x down here but at the bottom, I know that it's going to get multiplied by the 5 to give me 10x, because I'm going to go up and multiply it by the 5. But, so if I put the 2x down here, that will give me the 10x there. And so then all that leaves is me to put the x over here on the left-hand side of the lower box. And that should give me everything I need. That will give me 1x, and I can see, okay, now I have x times 2x, which is 2x squared. I have 10x and 1x, which will give me 11x, and 1 times 5, which gives me 5. So my final factored expression would be 2x plus 1 and x plus 5. So it's the same basic principle. You just have that little extra piece of having that extra 2 in there, which is going to change what you get in your outer and inner boxes. And you just have to think a little bit ahead. And say you try it once, so you put them the wrong way around, right? Not the end of the world. You just erase and know I've got to swap them, okay? So factoring is a lot of just giving it a go, checking it. If you don't have the right answer, swap it around. See if that gives you the right answer. If you don't get a right answer then, and there's another factor pair option, try the other factor pair option, right? It's just about working through things until you start to see the patterns, and then it becomes more automatic. All right, final one. This is a special case. What happens when the bx term, that middle piece, is missing, right? Well, not much really, but a question you always want to ask yourself, right? You always want to ask yourself, what are the factor pairs of negative 49? How could I get negative 49? In terms of whole numbers, there's really only one option. Well, actually, there's two options. There'd be 1 and negative 49. 1 and negative 49. -1 and 49, but the most obvious one is 7 and -7, okay? And a question you always want to ask yourself when you get a problem like this where the bx term is missing, ask yourself, are both terms perfect squares? And if they are, that makes your life really, really easy, okay? Because x squared is a perfect square because x is being squared, and 49 is a perfect square because it is 7 squared. And this is a special case called a difference of squares, and difference meaning subtraction. So two perfect squares are being subtracted. And when that happens, it's one of those automatic kind of, easily factorable ones. Because in order for that middle term to go away, right, that means that the outer and inner boxes, our two kind of middle boxes, have to cancel each other out, right? So, and if you look at your factor pair with 7 and -7, if you think of 7x and -7x being in those boxes, those are going to cancel each other out. So we go ahead and we say, okay, x times x, right? If we look, my most obvious factor pair option is 7 and -7, so I'm going to put a 7 and -7. Whoops, one of those was supposed to be negative, sorry. One should be 7 and one should be -7. Oh, here they come. Here come the negatives. So I've got x plus 7 on one side and x minus 7 on the other side, right? And that gives me, in those two middle boxes, one positive 7x, one negative 7x, which are going to combine to make 0. And, whoop, sorry, that just jumped ahead of me a little bit there. So as we go again, we would have x squared in that first box, positive 7x, negative 7x, and 49 in the minus 49 in the last box. I forgot to put the x squared in. Sorry. So we would get x plus 7 times x minus 7. And again, like I said, this is called a difference of squares. When you have the first and the last term are perfect squares and they're being subtracted, they have to be being subtracted. They can't be added. You can automatically know it'll just be x plus the square root of whatever your c term is times x minus the square root of whatever your c term is. So if it was x squared minus 25, for example, it'd be x plus 5 times x minus 5. Okay, so what I want you to do right now is essentially pause this slideshow. This is pretty much the end. And I want you to work on each of these 6 problems, right? Main focus is on the first 4. The last 2 are spicier because they're the ones that special cases that I gave you examples of. But focus on the first 4. If you can do the last 2 as well, that would be great. Hope you have a good day. Bye.